Existing uncertainties within interpreted data of geological, geophysical, and geochemical or 3G surveys are strongly influencing the drilling risk, especially setting the right casing design. Appropriately setting up the casing design holds the highest precedence in reducing geothermal drilling risk. This information is derived from the estimation of the total depth, well target, and potential drilling problems like lost circulation zone or lithology, and how the casing shoes should be set in the impermeable zone. These particulars serve as preliminary well design objective that should be prepared prior to the drilling program. Non-magmatic convection-dominated geothermal play systems are either fault-controlled or fault leakage-controlled. In purely fault-controlled play systems, convection occurs along the fault and is commonly combined within the filtration of meteoric water along the fault. In the fault leakage-controlled play systems, however, the fluid leaks from the fault into a permeable concealed zone. In turn, fluids can move from a permeable layer into the fault zone and from there to surface. As thermal fluids move away from the upwelling zone along a fault zone, they mix with cooler groundwater or meteoric water, as indicated by an increase of bicarbonate and magnesium and also decrease of boron, sulfate, and chloride. Olkaria in the eastern African Kenya is an example of a region consists of tectonically active intercontinental rift gravens. Their heat transfer processes predominantly consist of convective dominated one, hence this plate type also referred to as extensional domain type CP3 according to Moy classification. Olkaria Dome's geothermal field profile. High-temperature geothermal prospects in Kenya occur in the tectonically active Kenya Rift Valley and have an estimated potential over 3,000 MWE. The Rift Valley has experienced repeated volcanic activity and is associated with crustal upwarping and volcanism of mostly rhyolitic and trachytic rocks that started 20 MA. Existing geophysical models indicate that the upwelling of the asthenosphere provides the driving mechanism for the lithosphere to be uplifted and extended. Several geological, geophysical, and geochemical studies have been carried out in the Kenya Rift Valley to study and understand complex geological and tectonic setting of the rift. Olkaria Dome's OW902. We utilize the GeoTOR, an analytic tool in GeoSystem, to allow a quick simulation and integrations of MT, thermal manifestations, and topography informations of the well to be drilled. The embedded steam table and Monte Carlo simulations enable the results to be provided in a probabilistic manner, promoting better risk analysis in the exploration stage. We presented to you the joint MT time resistivity sections of Olkaria domes. For the input parameters for our GeoTOR, we can infer that the well ground elevations is 2000 MASL and the VOC elevations is 1200 to 2000 MASL. Since there is no boiling chloride spring noted, we utilize geothermometer quartz CO2 to infer the reservoir temperature, which is 225 to 291 degrees Celsius. We further confirm the actual TOR utilizing the first euhedral or epidote appearance data. We presented to you the histogram of the TOR elevation obtained from GeoTOR and also the cumulative frequency graph of Olkaria OW902. The relatively sloped curve shows that Olkaria OW902, indicating the uncertainty level of determining the TOR in these reservoirs, was relatively high. We inferred that the high uncertainty was due to the confirmation of the actual top of reservoir relies on the first euhedral epidote appearance instead of the pressure temperature profile. The actual TOR within this well is located in P60, which is denoted by the dot orange in the cumulative frequency graph of Olkaria OW902. Comparison with actual top of reservoir. The first appearance of epidote is from 780 MASL in well OW901, from 1225 MASL in well OW902, and from 955 MASL on well OW903 to the bottom of all the three wells. Epidotes show a systematic textural development within an increasing depth. In GeoTOR, of the top of reservoir is predicted under the P60, which we attached the table also obtained from the GEWA TOR. First, crystals are anhedral and form fine-grained aggregates, and in deeper zone they are idiomorphic, tabular, radiated, or fibrous. Epidote is found filling fractures, vesicles, and replacing primary plagioclase and pyroxene, and in most cases forms mineral associations with mainly quartz, chlorite, and sometimes calcite, auricite, and pyrite. All we can conclude that GeoTOR indeed can be utilized to estimate the top of geothermal reservoir for extensional domain type like Olkaria geothermal field reservoir. This is Jiwa. See you in the next video. Bye!